Okay, welcome to 2.1. We're going to talk about conditional statements. Did you know that your brain is basically a computer? It computes things with if and then, just like a computer does. If you hit the A button, then an A pops up on the computer screen, right? Your brain works the same exact way. So we're going to kind of try to hack our brains a little bit today and look at if-then statements called conditional statements. The if is the hypothesis. If this happens, then the conclusion happens. If hypothesis, then conclusion. That's how we define that. The hypothesis must happen before the conclusion. That makes sense to me. The conclusion is at the end. The if comes first, the hypothesis comes first, and then the conclusion comes. The conclusion is the results of the hypothesis being true. And the hypothesis could be false as well. Write the following statements in if-then form, underline the hypothesis, and circle the conclusion. Cheating on an exam is dishonorable. I'm just going to say it. You can write it. You can pause the video and write it. So here it goes. Cheating on an exam is dishonorable. If you cheat, then you are dishonorable. So, abbreviating, I'll write out the first one. If you cheat, then you are dishonorable. Alright, so basically what this is saying is cheating implies dishonor. Did you know that? Did you know that cheating implies dishonor? You bring dishonor on yourself and your family when you cheat. But that's not any of my students. Okay, so this is like abbreviating what it's saying. That's what your brain kind of does. Cheating on an exam is dishonorable. Cheating implies dishonor. That's what's happening. If you cheat, then you're dishonorable. Underline the hypothesis right there and circle the conclusion. Use the word implies. Cheating implies dishonorable. Next, angles that make a linear pair are adjacent. So here it goes. I'm just going to say it. You can write it. Write it as I say it. Pause it, rewind if you have to. If angles make a linear pair, then they are adjacent. So linear pair implies adjacent. If a linear pair, then adjacent. If a linear pair, then adjacent. Next, vertical angles are congruent. So we need to think about this one. Does vertical angles imply congruent, or is it congruent implies vertical angles? Does our brain interpret this as if vertical angles, then congruent, or if congruent, then vertical angles? How does our brain interpret this? The correct response to this is if you've got vertical angles, then you've got congruent angles. So this is the correct one. Vertical angles imply congruent. Does congruent imply vertical angles? Here's a situation where these angles are both 90 degrees. They are congruent, but they are not vertical. So congruent does not necessarily imply vertical. So the correct way to write this is if vertical, then congruent. If you wrote if congruent, then vertical, you'd get it wrong. What about this one? I cry when it snows. So, I need another piece of paper for this one. Ran out of room, sorry. Is this saying that crying implies snow, or is it saying that snow implies crying? If you're saying that this is the true statement, then you have magical powers that if you cry, then it snows. That's a magical power. This is probably what you're trying to say. This is what your brain is interpreting this as, is if it snows, then I cry. So even though snowing came last, the if is, the hypothesis is snow, and the conclusion is cry. If it snows, then I cry. If you wrote, if I cry, then it snows, you get that wrong. That is not true. That's not how the world works. Okay. So, a statement is called a conditional statement. We can write it as this with P implies Q with like a little arrow. I use double arrows. It just is how I was taught that. Our book uses this. So P implies Q. P implies Q, or another way of saying implies is if P, then Q. If it rains, then it's cloudy. All right? If it rains, then it's cloudy. Where does rain come from? Comes from a cloud. So try not to debate this too much. If there is a rain, if there is a drop of rain, there must have been a cloud at some point. If it rains, then it's cloudy. P implies Q, rain implies clouds. P is rain, Q is clouds, rain implies clouds. Is that true? Yes. We're going to say that. We're going to say that's true. Off to the side. The inverse of a statement. You get these little squiggly marks here. That's the notation for not. That means not, the squiggly. So not P implies not Q. Or if not P, then not Q. Here's how we would say that. If it does not rain, then it's not cloudy. So think about that for a second. Didn't you learn that a double negative canceled out, kind of, sort of thing? Well, here's a scenario. Is this a true statement? So this was a true statement. So shouldn't this also be a true statement? Well, let's look at it. If it does not rain, then it's not cloudy. Probably look outside right now. Is it cloudy? Yeah. Is it raining? No. So this is a false statement. If it does not rain, it could be cloudy. It's a false statement. Let's look at the converse. The converse is another type of way to flip something around. So converse is Q implies P. So it was P implies Q, and it gets flipped to Q implies P, or if Q, then P. So if it started as if it rains, then it's cloudy, the converse is if it's cloudy, then it rains. Think about that. Is that true? So we just flipped it around. If it's cloudy, it doesn't have to rain. That's a false statement. This is a false statement. It doesn't have to rain. And then the last type of statement is called a contra positive. And that is not Q implies not P. Or if not Q, then not P. Remember, this was like our P. This was like our Q. So if we're doing not Q, or if not Q, if it's not cloudy, Q, cloudy, then it's not rainy. Or it does not rain. What do you think of that? Is that a true statement? So pause the video and think about it. It is a true statement. If there's no clouds, then there's no rain, because rain comes from clouds. So that's interesting. We started with a true statement. We did a double negative and it turned into a false statement. We flipped it around and it was a false statement. We flipped it around and we double negative and it turned back into a true statement. That's interesting. Turns out that these two, the inverse and the converse, are called logically equivalent. They will either both be false or they will both be true. There's not a statement that exists where the inverse is true and the converse is false. They work together. And same thing with the statement and the contrapositive. These are logically equivalent. If the statement's true, the contrapositive is automatically true. If the statement is false, the contrapositive is automatically false, and vice versa. And then there's the case of something called a biconditional. A biconditional is a statement and a converse must both be true. The statement and converse must both be true. So this is not a biconditional because the statement is true but the converse is false. So not a biconditional. If it's a biconditional, we can use this abbreviation and we can say P implies Q and Q implies P. Or P if and only if Q. It's this. We use this saying if and only if for a biconditional. So here's an example. If 90% are above, then an A. That's true. Let's do the converse. So flip it.